if you want to follow along with this course, you have to install Python, preferably version 3.7 and above. You also need a text editor, which is Notepad++ or Visual Studio or VI. It's up to you which one you prefer. Of course, there are a ton of text editors out there, but whichever you choose, it's going to work. If you don't have a Python text editor, you can use the IDE which comes with Python interpreter. To open it, just go here and open it. Once you have opened it, you can start writing some codes here. Okay, we can do many operations such as addition. 2 plus 5, we get 7. 2 times 3, we get 6. 24 divided by 2, we get 12. Maybe 13 divided by 2 get 6.5. We can also find the remainder of a number. 7 modulus 2, you get 1. Of course, writing your code here in this window, when you close it, you are going to lose everything which you have been doing. That is why we usually create a file. To create a file, the first thing you need to do, you need to create a folder where you're going to store your file. I'm going to call mine PyCrash. Then press enter. Then I'm going to go back. And then from this window, go to File and then create new file. And then go to File and then Save As. Go to the folder which you've created. Mine is in desktop. And then put the name of the file here. I'm going to call this one intro. And then click Save. Once you've done that, you can start writing some codes. Okay. In mathematics, you are usually given this situation. This is a comment in Python. Basically, what happens is that when you initialize anything with this hash symbol, the Python is going to take this as a comment, which means it's going to interpret it when it is interpreting all the codes. It's going to interpret it as a comment, not as codes that need to be run. So whatever you write here, Python is going to treat it as a comment, not part of the program. So here in mathematics, you're usually given A is equal to 23, B is equal to C, B is equal to 2, maybe C is equal to 4. Of course, in mathematics, we use equal. But when writing codes in Python, equal is not an equal sign, it's an assignment operator. So the first thing that you're going to need to compute A plus B, then you are going to need a container that is going to hold this the elements or the items or the variables. So that is what you are going to need. Our first container is we are going to call it A, and then we are going to hold 23. And then the second one, we're going to call it B. Then we're going to hold 2. So now we can do some commutation. Sum is equal to A plus B. So A plus B, the sum of A and B is going to be held by this container called sum, which we call it a variable. So now we can print it out. Print. Want to print the sum of A and B. Basically, print is a function. We're going to learn more about function later on. So print is a function. Its only job is to print something into the screen. So here we've got another function here inside the format function. The format function, what happens here is that whatever you put inside the format A, B, C, and then the first one is going to display it in the first curly brace. Then the second one, which is B, is going to display it in the second curly brace. And the last one, the sum, is going to be displayed in the last curly brace. Okay, let us do this. Now let us print that to see what happens. To print, just the first thing you need to save a file. You can use Control S shortcut, and then go to run. You can use F5. So now we can see 23 plus 2 is equal to 25. So let us do another operation. Maybe let us do multiplication. So we're going to find the product of A and B, and we're going to print it out. A times B is equal, then you're going to use format, A, B, product. Control save, F5. So 23 times 2 is 46. Maybe you want to do some division. Div A divide by B. Then let us print it out. Print. I'm going to hold A here, divide, going to hold B here, then the answer here. Dot format A, B, div val. Control save, F5. 23 divided by 2 is 11.5. Of course, if I do want to find the remainder, I can just do this. Modulus mod val is equal. We assign A modulus. This is the percent sign is the modulus sign in Python. Of course, in other language, it's also the same concept. Mod. Let us print it. Print A modulus B, and then we're going to put the answer here. Dot format A, B, mod val, and let us print it out. Control save, run. So we have the 23 divided by 2 modulus 2, we get the remainder 1. So that is the remainder. Okay, we can also do some multiplications. We did some multiplication, division, subtraction. Even subtraction is possible. Maybe let us say difference div val, and let us put C minus B, and let us print val. Dot format C minus B div val Control save. So we have an error here. Let us take a look. Name C is not defined. Oh, we didn't define C. So we need to define C. C, we assign the value 4. Now we can save and then run again. So now 4 minus 2 is equal to 2. So these are the basic operations we can do in Python. Of course, as we were learning here, we saw many things. Whenever you are learning Python, you're going to hear people talking about what an integer is. We're going to talk about an integer. Basically, an integer, these are the values, the same principle that is applied to many. These are the values that doesn't have a decimal point. It can be maybe 2 or positive 2. So you can start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the positive values, and negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the negative values, including 0, of course. So that is an integer. So whenever you're doing an operation like print, maybe 1 plus 2, you're going to get an integer. One plus 2, you're going to get 3. So that is going to be an integer. But whenever I do an operation like this, like division, maybe let us say print, maybe 3 divided by 2. You're going to get a float. We have a float. In other languages, we call it a double. Of course, there is a float and a double in other languages, such as Java. So here, a number with a decimal point, we call it a double. We call it a float. So let us run and see. So here we got 1.5. Any number with a decimal point, we call it a float. Numbers such as 3.142, which stand for pi, so or 1.3333. So those numbers we call them floats. Any number with a decimal point, we call it a floating number. So another data type that usually have the basic one, we have what we call a string. A string is nothing other than an array of characters. For example, if you have a name, maybe username, and then you put here maybe Visa Dlamini. So this is an array of characters. So we can print that out. Print username, save, and run. So here we can see Visa Dlamini. So this is an array of characters. So we have initial, float, string. Of course, we do have other data types such as Boolean values. We've got Boolean values. So basically, they represent true or false values. Maybe you can say done is true. We use capital letters, true. Maybe not done, we are going to use false. So we're going to see their use as we go on in this lesson. So the next data type that we're going to take a look at in our second lesson, we're going to take a look at list. So let us jump to that lesson. Let us create a new file, save as, and we are going to call it list that type, and we are going to save, and we're going to put this here, and let us close this. So before we take a look at list, let us introduce a practical example where we are going to need list. Okay, imagine you need to count from 1 to 100 or from 1 to 20. So another circumstance when you're counting, you're going to say 1, 2, 3, 4, 5, 6, maybe 6. So once you've counted, you're going to need a storage where you're going to store this array of numbers. So that is where lists come into play. So here you can just maybe write numbers and then create this container 1, 2, 3, 4, 5, 6. So here we have an array of numbers from 1 to 6. So this is how we create a list. And we can do many operations here, such as adding another list. Let's say we wanted to add 7 from this list. We're going to say number dot append. We're going to append 7. Append 7. Let us save and run it. Okay, let us print it out. Print number. Maybe before we add that, print number. Yeah. Save and run. So here, as you can see, before we added 7, here we had 1, 2, 3, 4, 5, 6. We had an array of numbers from 1 to 6. And then after we added 7, now we have 1, 2, 3, 4, 5, 6, 7. So this number has been added. We can add another number, maybe number. Let us append 7. Append 8. We can print it out. So now we have number from 1 to 8. Of course, if we want to, we can remove that number. So we can use this function called pop, or this method called pop. We're going to write number dot pop. So by default, it's going to remove the last value here if we didn't specify which value to pop. So save, run. Okay, let us print it out. Print number. Maybe let us put here pop. So here, we popped this number, we removed this number at the end of the list. We removed 8 by using this function pop. Of course, if you have a situation whereby we have another list, maybe num2, maybe we've got here 9, 10, 11, maybe 12. So we can combine it, we can concatenate these two lists. So there are 2 ways basically to do that. The first one, we can use extend. So to extend this one, maybe let us say we want to extend number dot extend, and then we are going to put num2. And let us print and see what happens. Print number. Save and run. So now, as you can see, we have extended this the original. We have extended the original list or the list that we had before. Now, after we popped it, is we popped 8, so we've extended it. We've added 10, 11, 12, 9, 10, 11, 12. So that is how we add the list. Of course, another way of achieving the same thing, maybe let us say num maybe 3, and let us put maybe 12, 13, 14, maybe 15. So another thing that we can do, so let us create a new one. We're going to call this combine numbers, and we're going to put num number 1 plus maybe num 3, and let us print it out to see what happens. Of course, errors are bound to happen, so whenever you see an error, don't panic. That is normal. Let us save and print. So now we've concatenated these two lists, number and num3. Now they are together. So we've concatenated, and after concatenating them, we have inserted it into a new container. We call this combined numbers. Okay, of course there are many methods that are associated with this class list, and we are going to see most of them as we are continuing with our lessons. So that is all we need to learn about list at this point in time. As we go later on, we're going to use other functions to manipulate list. So you can just search them, quickly them online, and you can see a ton of them. We have slice, we've got the remove, or no, there are a ton of them there out there. So you can just go ahead and quickly them. So thank you for this. Thank you guys for staying tuned in this lesson. Please stay tuned for our next lesson. In our next lesson, we are going to learn about the while loop, and for loop. Of course, we are going to combine it with this new concept of list, which we have already learned. So thank you guys. Stay tuned for our next lesson. Okay, let us create a new file, and let us save it. Save as, and we are going to call this loops. Yeah, just loops. So now let us close this one. So to create a loop, it is very easy in Python. There are two types of loops that we normally have. We've got the while loop and the for loop. So let us start by creating the while loop. While loop. Let us say we want to count from 1 to 6 or 1 to 10. So we're going to count from 1 to 10. First, we need to initialize our val. Since we are going to start from 1, we're going to say I is equal to 1. We're initializing it, and we're going to say we're going to loop as long as I is less than or equal to 10. That is what we are telling our loop to do. Give me some numbers from 1. Count it from 1 to 10. As long as this is true, please continue looping. So as long as this is true, please continue looping. And as you are doing that, I want you to print that out in the screen. So I'm going to print I. And then to avoid to have an infinite loop, we need to put it this. So we need to put this operation at the end. So we are going to increment I by 1 as we are going through this loop. So that is what we are going to do. So now we can print it on the screen to see what happened. Let us save and run. Okay, indentation is very important in Python. So if you put some indentation where it is not necessary, it's going to give you an error. Save and run. Of course, I didn't correct that one. Save, run. So here we have 1 to 10. So that is how we use a loop. Of course, we can remove this 10 here, put n, a variable. So this will help us. We don't necessarily need to come here and change this the value here. We can assign 10 here. So this is going to make our code cleaner and easy to manage. So let us save and run. Even if you want to count from 1 to 100, you can just put 100 on the on our variable n and then run. Save, run. So we can count from 1 to 100 in minutes of a second. So that is how we use the while loop. Let us take a look at the for loop. We are going to also do some counting here. For loop. The for loop, to initialize the for loop, you just write for and then put here we don't have to put like I is equal to 1, just the same way we did in the while loop. Here we just put you can put I here, I use in and then range. This is a function. It basically takes three input. You can put 1. You can put 1 or 0. It's up to you where you want to where you want to start counting. Here we in the while loop we specifically stated that we want to start from 1. So maybe here we can specifically state that we want to start from 1. If you don't put 1, it's going to think that you want to start from 0 by default. And then the second option, you're going to put maybe where you want to end. I want to end maybe start from 1 and then end here we said we want to end, we wanted to count from 1 to 10. Of course, the less than or equal to sign enable us to put it to be able to count from 1 to 10. If we didn't put it the equal to, it was going to count from 1 to 9. Maybe let us clear the screen to see what happened. Okay, before we do that, let us comment this one. Okay, save, run. So as you can see, we are counting from 1 to 9. So the equal to sign enabled us to count from 1 to 10. So here in the for loop, we have this situation whereby we don't have the equal, we only count from this number that we've mentioned, maybe to 9. 1 to, and so here we're going to count from 1 to 9. So by default, it's going to count from 1 to 9, not 1 to 10. If you want to count from 1 to 10, you need to put 1 to 11. So it's going to count from 1 to 11. Let us print it out to see what happens. Print. Let's print. Let us change this one maybe to J so that we can see the difference. So let us print it. We want to start from 1 to 11. Or let us go to maybe to 20. So it's going to count from 1 to 19. Save. And then run. Okay, let us comment this one out. Or let's just put a print put some line here and write 4. Save and run. So we can see here we are able to count from 1 to 19. Of course, just like before, we can just put here a container instead of the real numbers. So here we can just maybe say n to 20. Save and then run. So we're able. So this comes in hand in this situation. We can solve our dilemma that we have here. Instead of counting from 1, we wanted to count from 1 to 20. So now that we have a variable like n here, we can just put +1. So in that way we are going to compensate this, or we're going to solve this problem that we have, that of counting from 1 to 19. So let us see what happens. 1 to 20. So that is how we use the while and the for loop. Okay, now that we have this information, let us counting from 1 to 20 is interesting. Now let us put this information or this data that we have in an array. Last time, an array is a list. The last time we had this situation where of counting num 1, 2, 3, 4, 5, 6, of counting from 1 to 6. So it was interesting of doing that. We can also achieve the same thing using a loop. So here, remember last time we were using append, so we're going to use that method to put some value here. So here we can use the for loop, maybe for j in range. Maybe we're going to start from 1 to end in 6. I'm going to add 1 here, and then we're going to put, so we're going to say num dot append, and then we're going to append j. So let us initialize n, and we're going to put 6 here. Let us print. I'm going to write after here. And then num, and then let us copy this and paste here. Let us put before. Let's put before. So let us print that out to see what happens. Save, run. As you can see, before the list was empty, then after, now it is not empty. We've got 1, 2, 3, 4, 5, 6. That is what we add in, to add items into a list using a for loop. So thank you everyone for this lesson. Please stay tuned for our next lesson. In our next lesson, we're going to take a look at functions. So we'll be taking a look at functions. Yeah, we're going to take a look at functions. We're going to combine the knowledge of functions with all this information you have already learned. Addition, subtraction, loops, list. Yeah. Okay. Let us create a new file. And we're going to save it. Save as. And then going to call it functions. And then save it. So last time we did introduce a function. The first thing that we did introduce a function. The print was a function. Its job was to take a string hello and print it out. So here we can, with this function, this is a built-in function. So now we can print this one hello world and save. Let us run. Okay, let us create a new window. Save. So here we're able to print hello world using this print function. So we can create our own function, such as this one, def. Maybe want to add items, add. To create a function, you need to write def for defining a function, and the name of the function here, we call it add. We're going to add values, and it's going to take inputs here. Just like in mathematics, when you're given the situation whereby you're given f of x is equal to x plus 2. You can also do that. Let us put f of x here, and we are going to put x inside x, and then after we are going to put this information, we're going to return the sum of x plus and 2. So x plus 2. So what will happen here, basically, f is going to receive input, maybe let's say 2, and then it's going to process it. Instead of in place of x, what is going to happen? X is going to be replaced by 2. So this is a machine. I could put in something here and replacing it here. So 2 plus 2. So the output will be 2 plus 2. The output will be 4. That is what we're expecting to happen here. So we can print this input out, this function out. Print f of 2. Let us print it out. Save and run. So we have 4 here in this function. And we can do another one. Print f of 3. Let us see the output. Save, run. So we have 5. Basically, that is how we create a function. Okay, now let us create a function that will perform some or maybe let us do the other operation that we had. So instead of writing maybe the sum of a plus b, the problem with this method of writing codes is that we cannot reuse this code, so it is not reusable. Once we do some operation here, we cannot reuse it in another program or in another place. That is why we need function. One advantage that comes with functions is that they are reusable. So here we can say def add, maybe we want to add a and b, and let us return that a plus b. So we can reuse this function. So to do some addition, we can just say print, and we are going to put add. We are going to put 2 values, 2 and 4. Of course, we know the expected result is 6, and then let us run. So we have 6 here as expected. So now if I can reuse this function again and again, maybe here I can put 5. Maybe here I can put 7. Okay, to make this thing more interesting, let us remove this one. Let us assign 2 variables. A, we're going to assign, we're going to put a value 4. B, we're going to put 5. Now we can say sum, maybe A, B. I'm going to use this function a, b. So now we can print it out. Print A, B, A, B, A, B, maybe some A, B. Okay, let us print it out. Save and run. So now we have 4 plus 5 is equal to 9. The good thing about this is that we can reuse the function again and again, maybe 100 times if you want to. Let us say now we want to change it. Let us just change here. Maybe let us put 2, 4, and put the function at 2, 4. Another one. Maybe let us put 3, 7, and put this function at 3, 7. Okay, let me put the last bracket. And here again. Okay, let us execute that code to see if there's an error. This looks like there's an error here. Want to be an error. Okay. Now save, run. So now we have 2 plus 4 is equal to 6, 7 plus 3 is equal to 10. Of course, we can create other functions such as def, maybe mult, and say A, B. It's up to you whether you want to put X or Y. It's up to you what you want to put inside these two as input argument. So maybe here I want to return A times B. A times B. Or maybe I want to do some division. Div, maybe AB. And I want to return A divided by B. Maybe I want to return some modulus mod val AB, and I want to return A modulus B. Or do some subtraction, div sub and I want to return A minus B. So this is how we create functions in. So bear in mind that there are some functions that are already built in Python. So recreating the same function is a waste of time. So you can just go ahead and Google before you decide to create a function. It is advisable that you just go online and Google if there is any function that can do this operation that you want to do. If there isn't any function that can do the operation you want to do, then you can create it. But most of the time you're going to find that there are already functions that are out there that can do the operation that you want to do. So you can do that. For mathematics, go and search just the maths module for Python, and then you can just check if there's anything in there that you need or you don't need. So that is what you can do. So this is how we build functions in Python. Now let us take a look at how to integrate this new knowledge that we have with the list. So let us create a new file. new, and save as. I'm going to call this functions list, and then I'm going to save it. Okay. Under normal circumstances, when you're given function like f of x in mathematics, and maybe x plus 2, so you find that you are given maybe in the input, we are given the input, which you normally call it the domain. So maybe let's call it domain, and we're going to put an array. Maybe the input 1, the domain is 1, 2, 3, 4, 5, 6. So what they are generally expecting here, they're expecting you to write, to do something like this. Of course, this is in mathematics. For f of x, maybe x plus 2. So what we are normally going to have for the domain, you are going to have maybe 1, and then the output is going to be maybe 2 plus 1, you're going to have 3. Maybe for 2, 2 plus 2, 4, and we are going to have maybe 3. 3 plus 2, we're expecting 5. And then we're going to have 5, 4, and 4 plus 4, or 4 plus 2, we're expecting 6. And then maybe okay, we have 5, 5, 5 plus 2 is, we are expecting 7. Last but not least, we have 6. 6 plus 2, we're expecting 8. Okay, let us extend this one and this one. This one, this one, so that right now we can have here the range, which is basically the output in a function. In mathematics, the domain here with the input. So with the input and the output. So our job right now is to create a program that is going to display this the input and the output. So we're going to create an operation using this function. With the knowledge we have right now, we can create a list that is going to take this input, and maybe this input 1, 2, 3, 4, 5, 6. Let us do that. And we are going to call it domain values, and we are going to create an empty list. What we're going to do, we're going to create a function. No, not a function. Let us populate this with values from 1 to 6. So let us initiate. We are going to put values from 1 to 6. Let's put n is equal to 6, and let us assign 6 into n, and let us use the for loop for I in range, and we are going to start from 1. We are going to end in 6, and then I'm going to say, now we are going to append all these these range values from 1 to 6 into this list we have. Domain values dot append I. So this is what we were expecting to happen. So this is the domain holders or domain container. And here, so we are populating a domain container with values from 1 to 6. So that is what we're doing. Okay, let us see if we have achieved what we want to achieve. Let us print that out. Print. Let us print to see what is inside the domain values after populating it. The domain container. And let us print it to the screen. Let us save it and run. So now we have 1, 2, 3, 4, 5, 6. Those values we have populated in. Now it is time for us to create a function that we can input this argument into, and then at the end get this output. So the next step is to create the function that will do that. So we're going to have a function def, and we're going to call it f of x, and then we're going to want to return x plus 2. So this is the function f of x is equal to x plus 2. Now what is left for us is to insert the input inside x, inside f of x, and then get the output in the range. So what we're going to do, we are going to let us create a function, and we are going to call it the output. Yeah, the output def, let us call it range, range values, and then create an array. This array is going to hold the range values. Okay, this array is going to hold the range values. What now we are going to do, we are going to loop into this to the array, the domain values array, for I in range, for I in domain values, and then so we're going to look through each element, and then we are going to take that element res dot append so we are going to take that element after looping all those elements inside domain values, and we are going to put them inside the function f of x. So this is what we're doing here. And then after doing that, the results of the results of the addition of 2 inside this the domain values, we are going to insert into res, and then at the end we are going to return the results into this function. We're going to return res, so we're going to return an array. So it's more like we're going to return maybe the first one is 1 plus 2. We're going to return 3, an array of 3, and then 2 plus 2, we're going to return 4. Yeah, something like this. So this is what is going to happen. Maybe before we do that, let us do some printing here. and let us print to see what is inside it is let us print res. Okay, let us call this function to see the range of values function. When you're calling it, you are just calling this function. We want to call it to be able to call this function, the inside function, the printer, the res, the print function that contains the res list. We need to call this function range values. Let us save it and see what happens. Okay. So as you can see, I've got 3, 4, 5, 6, 7, 8. So what we are printing here, this is the function we are printing. We are printing out. This is the list we are printing. 3, 4, 5, 6. We are printing it here. So if you can try to do this, maybe let us say range, maybe values, range value, and if you can try to print here, let us see what happens. Now we are printing the function. We remember we've removed this print function, which means we are no longer going to get these items using the print function. But we're going to try to see whether we can do this using this by assigning the return value of range values into this variable range value. So we are printing range value here, and then save and then run. Okay, it seems like everything is clear, is in order. We are able to get this output. And let us test it again to see if it's not just a mistake. Values. And F5. So we can see we are able to return these values using the so basically here what happens is that when we return here, we return this array. The array is going to be inserted inside the range values, so it's going to be returned here. So basically here, this one is now is a placeholder that hold this returned value res. So let us check the type of it. Print type, maybe range values. Save, run. So they say this is a class function. So this is a class function. And let us see what is returning. Print type, open brackets, domain, values. So I want to see the type. So here, so basically here we are returning a function. This function, the class function, is holding this is holding the array, the list values, the output, and this class function is holding this class list is holding the domain values. So we can print that out here in the screen now. Let us imitate that. Okay, what we want to do right now is to imitate this output in this comment. On this comment is to imitate this output on this comment. So basically what we have here is we have the input on this side, and then we have the output on this side, which we call it a range. So we have the output on this side, and then the input on this side. So basically we want to imitate that on the, or we want to print it out. So we are going to do that right now. Okay, to be able to print out, we need to create a list of key value pairs, more like a dictionary. And we can achieve that by using the zip function. So we're going to use a for loop and then say for x, y in, then you're going to put zip, and then you're going to put the domain here, domain values, and then you're going to put range values. So once we have that, we can print that on the screen. I'm going to say print, and then this is going to call the hold x coordinates, and this is going to hold the y coordinates, and then format. So I'm going to put x here, then I'm going to put y here. So now we are ready to print this output. Okay, let us check if everything is correct. Domain values, and then we have range values. So we have everything in order. Let us print that out to see what happens. Okay, save and then run. Okay, here we have an error here. Domain, okay, we have a spelling mistake here. Domain values, and then range values. And then let us run again. Okay, as you can see here, we're able to print this output and the way with the way with the in this comment. So we're able to print the same values. So that's how we use functions. So that is how we define function and use them. So please stay tuned for our next lesson. In our next lesson, we're going to be taking a look at dictionaries, tuples, dictionaries and tuples. So thank you everyone for your time. Please stay tuned for our next lesson.